Welcome to Vision Plus and welcome back to S.4 Mathematics. We are looking at the turning points of the curve. Example 5, which is the last example, part A says, find the turning points of the curve and distinguish between them. So in part A, the curve is given by y equals to x cubed minus 3x squared plus 2. That is the curve, and we need the turning points. What do we know at the turning points? We know that at any turning point, dy dx is 0. In other words, the gradient of the curve at the turning point is 0. That means we need the gradient function of the curve to assist us find the coordinates of the turning point. So we differentiate the curve. Dy dx becomes 3x squared minus 6x. That is the gradient function of the curve at any point. But we know that at the turning point, at turning points, at any turning point, the gradient is 0. Therefore, dy dx is 0. Since we know that the gradient is 0, we can use the gradient function to get the values of x for which the gradient is 0 at the turning point. Therefore, 0 equals to 3x squared minus 6x. This is a quadratic equation that you can solve by any method, but I'm factorizing in this case. Therefore, 0 equals to 3x is common, factor it out, into x minus 2. Make sure you know factorization. Yes, so we have factorized. Therefore, either 3x equals to 0. Therefore, in this case, x is 0, or x minus 2 is 0. And in this case, x is positive 2. Let me press the calculator and see if my values are correct. I come to equation, the degree of 2. I will have 3, negative 6, 0. X is 2 or x is 0. Those are the values that I have obtained. So these are the two values of x at the turning points. Okay, that means we have two turning points. We have a turning point when x is 0 and a turning point when x is 2. Now let us get the corresponding values of y at the turning point. That means we shall use the equation of the curve. Why? Because the turning points are on the curve. These 0 and 2 are on the curve. So let's get the corresponding values of y. So for x is 0 on the turning point, y becomes, where I will find x in the function of the curve, we put 0. So we shall have 0 cube minus 3, x is 0 squared plus 2. And in this case, I'm getting 2. Let me use a calculator. Please always use a calculator to avoid errors. We are saying our x is 0. Yes, it is 2. So at the turning point when x is 0, y is 2. So the coordinate point at that turning point is 0 and 2. And then you go to the other turning point when x is 2. So when x is 2 at the turning point, what is the corresponding value of y at that turning point? So y equals to, substitute for x in the function of the curve. So we shall have 2 or 3 minus 2 squared minus 3. Then you press the calculator. This is 8. This is like 8 minus 3. I'm getting 3. Simplify it, please. Because 2 power 3 is 8. Minus 2 into 2 squared minus 3. I'm getting negative 3, by the way. It is not positive 3. Negative 3. That is why it is important to use a calculator. Don't think you can do it in your head. Now, when x is 2, y is negative 3. So the turning point as a coordinate point is 2 and negative 3. Let me prove that quickly. After getting an error, my trust issues will set in. Plus 2. What is the value of x? Negative 3. What is the value of x is here? 2. And it is showing me that we are supposed to get negative 2. I don't know where the mistake is. Let me verify quickly. X cubed, right? Which is 2. 2 cubed minus, oh, I've seen a mistake. This is where the mistake is. Okay? It is x cubed minus 3. Our x is now 2 squared plus 2. Yes. This gives us here 8 minus 12. Right? Minus 12 plus 2. And then we proceed. That gives us negative 2. Yes. So please always try to verify the answers first. X squared minus 3x plus 2. X cubed minus 3x squared plus 2. X is 2. Negative 2. So this is the next coordinate points. Now let us distinguish them because the question has said you can distinguish them. That means for us to distinguish, there are two methods which I'm using. The method of getting the second derivative, which is b squared y dx squared. That means we need to differentiate the gradient function of the curve again. And the gradient function is 3x squared minus 6x. So for us to get the second derivative d squared y dx squared, we need to differentiate this again, giving us 6x minus 6. So we shall use the second derivative to test for the 2 points. So I'm going to test for the first point here, and the first point is 0 and 2. Then I will test for the second point here. Second point is 2 and negative 2. Now, we know that this is x, this is y. We shall use the gradient function for the 2 points. So we are going to substitute for x in the gradient function of the curve. In the second derivative function of the curve, x is 0. So we have 6 times 0 minus 6. This here gives me negative 6. Then you judge, is negative 6 more than 0, is it equal to 0 or less than 0? Any negative number is less than 0. So we say if d squared 1 dx squared is less than 0, it means we have maximum stationary point or turning point. Therefore, this implies that the point 0 and 2 is the maximum turning point. Like that. Now we go to the second point. Now we don't expect the second point to be a maximum turning point, because if one point is maximum, the other should be minimum or the point of inflection. Now let us test for this point. This is x, this is y. We use the second derivative expression, b squared y dx squared equals to 6. What is our x in this case? Our x is 2 minus 6. This here gives us 12 minus 6 is 6. This is the value of the second derivative. Now we judge. If 6 is more than 0, is it equal to 0 or it is less than 0? 6 is more than 0. And we said that if the value of the second derivative is more than 0, then we have a minimum turning point. Turning point. What is the implication has? It implies that the point 2 and negative 2 is a minimum turning point. Okay, therefore that is the solution to example 5.